Because balls, if I drop a ball...
Balls? You can suck my balls.
This phenomena creates a slight force in that downward vector, because as soon as we leave the ground, we start becoming positively charged by the air around us and are now forced towards the negative of the ground. This is electrostatic acceleration. One might think that the attraction from above and below would cancel out completely, but it is the electrostatic gradient that creates a flow from the positive above to the negative below. Think of the Earth as a flat strainer, and there is a constant flow of water from above, moving very slowly, always applying a force in a downward direction. This would be considered
There are three main states or kinds of matter: solid, liquid, or gas. A solid is something that holds its shape. A solid means that the atoms are packed in really close together so they can't move, which means the object holds its shape. A liquid, on the other hand, will always change its shape. It changes shape to fit the shape of the container it's put in.
One of these bulbs, some bromine, and in the other I have a vacuum. And if I open the tap between these two, you will see spontaneously the bromine rush from one to the other. Now that is the simplest change we can have, perhaps, because all that happens is a change in entropy. In this case, the expansion into a vacuum, nothing else is involved. There's no energy change, there's no temperature change, there's no change except entropy. So without the entropy...
You've got a pressurized system. We all observe gas pressure. We're breathing it in and out right now. But it's right next to a vacuum. So there's no lid, in essence.
That's why we ask, show us the non-physical container.
Gee, I'm not so sure I can make this any simpler, but I'll try. Imagine you've got some perfectly bouncy balls in a fish tank, and the fish tank has no lid on it, and none of those balls have enough energy to bounce out of the box. Now imagine those balls are actually gas molecules, and boom, you have a lidless container.
Liquids are sometimes thick like honey or thin like water, but no matter what, they'll always flow. Atoms in a liquid can move around, but they'll stay together. A gas, like a liquid, takes the shape of the container it's in, but will also spread out to fill the container. When a balloon fills with water, the water fills up the bottom first, but when you fill it with a gas, the gas fills the whole balloon. Heat from the sun warms the water. This turns the liquid water into a gas or water vapor, which rises into the air. This is known as evaporation. As the water vapor moves up, the vapor moves up, the vapor moves up.
Now imagine those balls are actually gas molecules, and boom!
The vapor moves up higher and higher into the sky. It starts to cool down, turning back into tiny droplets of liquid water. A liquid can flow, which means it can be poured. So if you pour water into a fishbowl, it moves to become the shape of the fishbowl. This is known as condensation and is what causes clouds to form.
Now imagine those balls are actually gas molecules, and boom!
They become too heavy to stay in the air and fall back down to Earth as rain, hail, or snow. Once on the ground, they'll eventually warm and melt and turn back into a liquid. This water is then evaporated up by the sun, up by the sun, and this goes on and on.
And that's why they don't disappear off. It's really, really simple.
How do you weigh a gas?
A 9-year... Sorry?
How do you weigh a gas?
Okay.
Describe the process.
You would put it in a container.
So you need a container then, but inside that container, the gas is expanding in all directions inside the container.
Yeah.
Yeah. So if it didn't have that container, it wouldn't be pressing down. It would be expanding in all directions, all vectors. Not a downward vector. All vectors, same as when it was in the container being weighed. All vectors, not just down.
In nature, the way water keeps changing states is called the water cycle. Rain is part of the water cycle.
Now imagine those balls are actually gas molecules. And boom, boom, boom.
I just need to breathe to know that there's not a vacuum above my head. Debunking the idea, the notion, the model. Even earlier, were you not listening when Rumpus told us that natural law doesn't apply to your model and atmosphere? That this isn't applicable with natural law, or it doesn't jive? When we're talking about something that you've brought up, in this case the V in PV equals nRT, you've got a problem. The V is space.
No, we don't. Not at all.
Where'd you get the
No
V?
problem whatsoever.
Okay, Earth is a sphere. Where'd you get the V?
There is no fixed volume for the atmosphere.
Well, in PV equals nRT, it's got a V. So where'd you get it?
That equation does not apply to the atmosphere because there's no...
Sorry, the equation doesn't apply to the air we're breathing. This is a law of nature. Why would you say it doesn't apply to air? Seems very peculiar. Boom. Does gas go down, go boom, boom?
Absolutely it does, yes.
Boom, boom.
Really? So if I put gas on a scale, I can weigh it, can I?
Yeah, put it in a vacuum and you can weigh that, yeah.
Put it in a vacuum? Why would I need to put it in a vacuum? You mean a container? Sorry, just gas?
Well, gas tends to wander about, so you need to keep it somewhere.
Wander about? Doesn't it stay on the scale for you to weigh it with this arbitrary downward vector?
It will run around, so you need to keep it
Run
somewhere.
around? What the hell's it doing running around and not obeying gravity? Why isn't it going down, go boom, boom to be weighed on the scale then?
Because balls. If I drop a ball...
Balls? You can suck my balls. Yeah, your sky vacuum, when it comes to natural law, it's not even applicable, mate. Not even close to being applied with natural law. Your atmosphere, your sphere-shaped air, in a vacuum without containment. You can't even apply natural law to that. If the sky was a vacuum, there'd be no containment. Yeah, just covered this. And the gas we breathe would fill the space. It would be the availability of volume. Your sky is a vast space for gas to fill, and gas would just fill it. If it was 10 to the minus 17 torr vacuum, then the gas we're breathing would be filling it.